Assalamualaikum and hi everyone. We are from Group E. Would like to present about control charts for variables and control charts for attributes. For control charts for variables, we are going to show you how we plot our chart using our programming. So I'm Ayufa Hana binti Amir Hamza. I'm going to show you how I plot R and X bar chart in R. So for the first step, you need to install a package named QCC. So if you haven't installed, just click install, type QCC and click install. So I already installed it, so it will appear here. So you want to use this package, right? So how can you call your package? So just type library QCC and run, or you can just click this box over here. So from the example in the question, there are data given. So how can you enter your data in R? So I'm going to enter my data manually. And of course, there are other choices too, such as you can import your data from the Excel. So how can I manually enter my data? So just choose any variable name. So I choose call equals to data.frame. So data.frame is you need to write this to make your table of data. So we want to edit the data, so we can enter our data in it. So just call equals to edit call. So if you run this, it will appear like this. So at first it is empty and blank, so you just need to enter all the data in here and make sure that every variables are numeric as we use numbers. So just click enter, and to save this data, just click X. So we want to call our coil data so we can see the data clearly. So just type call and run. So these are our data that we just entered just now, 25 and here. So first we want to make R chart. So I take a variable name. So a equals to QCC. What is your data name? So my data name is call, comma, type equals to what is the chart I want to make. So R chart. So just type R. So if you run this, it will show you the R chart. So from this R chart, it is not in control as there are 2 points that are not that are out of the control limit. So let's look at the X bar chart. So for X bar chart, I use B equals to QCC coil comma type X bar chart. So if you run this, these are our X bar chart and it is in control. So in this X bar chart and also the R chart previously, it already listed the center, the LCL and the UCL as well. And over here you can see the number of beyond limits. So here it is in control, so it is 0. But in R, previously, it shows that the number beyond limit is 2. So these are the points that are out of the control. So from the R chart previously, it is not in control, so we need to redo our R and also X bar chart. So we need to eliminate the 13th data and also the 19th data. So our new data name is new coil. So new coil equals to data.frame. New coil equals to edit when we want to edit the data. So edit new coil. So if you run this, of course, at first it is empty. So just enter your data. So now it is 23, and make sure the variables is numeric. And to save, just click X. And if we call our new coil, to see our new data. So here is our new data. And for the same step for our chart, just I use new variable name C equals to QCC. What is your data name? So new call, comma type. So we want to make R chart. So if you run, we already have our R chart, which is in control. So for X bar chart, the same step, but new variable. So D equals to QCC, our data name, new call, type, X bar. So if we run this is our new X bar chart. So it is in control as well. And as you can see, I put this summary for the chart. So you can see for better input. So if we run this summaries for C, you can see it summarize your chart. So it shows you the group statistic, the group sample size, number of groups, the center, the standard deviation, and also the control limits. So it is the same for summary D. And I think that's all for how I plot my data for R and X bar chart in R. Thank you.
Hello everyone, my name is Lowikit from Group E. I'm going to introduce the way of plotting control charts for variable, which is the control charts for mean and standard deviations by using R programming. I'm going to use the package QCC in R programming to plot my S chart and X bar charts. Here is the questions I'm going to plot. The thickness of magnetic coatings on audio tapes is an important characteristic. Random sample of size 4 are selected, and the thickness is measured using an optical instrument. The table below shows the mean X bars and standard deviations for 20 samples. The specifications are 38 plus minus 4.5 microns. If a coating thickness is less than specifications call for, that text can be used for different purposes by running it through another coating operations. Assumes the distributions of thickness of coating is following a normal distribution. Okay, now after finish investigate the questions, I realized that the question only provides us the sample means and sample standard deviations. But worth to mentioning the QCC package required the data haven't been processed. This means we need to have more data for each samples to run our QCC package. So my plan is to generate 4 data for each samples that fit in by their sample mean and sample standard deviations. Okay, first I put these data into the Excel. Okay, their samples and their sample means and their sample standard deviations in the file who named book 1. Now let's go. Okay. I applied 4 different packages in these questions, which is matrix stats, QCC, write XLs, and read XLs. I will explain which functions I use in package later. First, I use the functions read XLs in readXL package to load my data that plays in the Excels with I already mentioned the book 1. Okay, now I'm going to load this first. Okay. Okay, let us see, is it our data import correctly? It seems no problems. Okay. Now, before we start our next step, we need to attach our data first to make sure our data is attached to the R search path. So attach our data. Going to generate active random numbers from 0 to 1 with the run if functions. We need and the run if functions is the functions that generate uniform random number, and after this we need to spread the active random numbers with is from 0 to 1 into 4 groups, and each group contain 20 random generated numbers. Okay, since our data already generated successful, so to make sure we clearly understand what we are done now, I will use the data frames to show our data. Okay, here is our data. This is the random number I generate just now by the run if functions, and then we will use this random number to generate our data that fits in their sample mean and sample standard deviations. Next, we're going to use the QNOM functions in the basic functions that's similar to the inverse normal found in our calculator. This will generate the numbers by given the probability, which is from 0 to 1, and then the sample mean and sample standard deviations. Since we have 4 random numbers, because we need to generate 4 different data for each samples, so can run now. Okay, already success. And then we need to test is it our data fit in our standard deviations, sample standard deviations and sample mean. I put them in the data frame first, so we clearly know what we are doing. And then view out. Okay, now we need to use this to find the mean and the standard deviations for each row to check is it if it is our sample means and sample standard deviations. Okay, for this the row mean function is used. The row mean function is used. And then but something different to the row mean functions. We need to put our data inside a metric first by using the data.metric functions, because we need to use the row standard deviations in the metric stats package. So we need to follow their formats. We put that into the metric first, and then we calculate the standard deviations for each row. Okay, let us put again into the data frame, check whether our means and standard deviations generated by the random numbers, is it fit into our sample means and sample standard deviations. Okay, we compare. It seems different because I think the main reason is because the generated data are not big enough, only 4 of data for each samples. So the inverse normals need more data, need to generate more data to more closer to the sample means and sample standard deviations. But never mind. I going to solve this. For solve these problems, I going to apply the following formula. I use the sample means, which is the mean we expect plus the generated uh, data, minus their means, and then time which the sample standard deviations divide by their standard deviations for each data for each data. So I'm going to run this. Okay, it seems success already. So I put it again into data frame, then view the data. Okay, ready generate. Now we repeat the step again. Check whether this data fits in our sample means and sample standard deviations. This. Okay. And it seems our data already fits in our means for the generated data, and the standard deviations for our generated data already fits in our expected sample means and sample standard deviations. So this is the data we going to apply in the QCC package. Okay, so because for the QCC package we only need this for data, so I will put them along in one data frame. And then by using the right XL SX functions in the right XL, and then we save the names. This is the data we will save into the Excel form. Okay. Okay. Okay, it seems our data already saved into here. Okay, now I need to rearrange our data into the formats that required by the QCC. But since that is the random number generate difference each time, I will use the data already arranged for last run of these programs, which is my data. This is this. We need to arrange in these forms to follow the format of the QCC. So now I go to import our data. Our data. Okay, now we can see our data is successfully imported into the R programming. Okay, now as I mentioned just now, we need to attach our data first, and then we will use the QCC groups functions to put our data in the QCC formats required by the QCC package. Okay, here we can see what is the format required by the QCC package. This is the format. Okay, now with the QCC functions in the QCC package, we can put in our data, and then for the S bar, we use the type S, okay, to generate our plot, the control chart, to plot our control chart. Okay, now here is our S chart. Here is our S chart already successfully generated. And then since there is no outlier, and then this was normal to the S chart situations, so we can directly go into generate the our X bar charts. But we need to mention, we need to take attention that we need to use the functions, the UFXD in the standard deviations format. Okay. Now the X bar chart also successfully generated. Okay, that's all is my presentations. Thank you.
Moving on to the control charts for attributes. So I am going to plot for P chart, the first chart. So as the question, these data are already given. So we just need to find the control limit, which is the P bar, upper control limit, and also the lower control limit. So for P bar, these are the formula. So I use this summation of x divided by n times g. So here P bar. So the summation of x is 90 and divided by n times g, which n is 50 and g is 25. We got 1250. So as you can see, I freeze both cells because the bottom cell over here, we need to use the same value, which is 90 and also 1250. If we do not freeze this cell, if we slide it down like this, it will have different values. So for UCL, the formula is P bar plus 3 times square root of P bar times 1 minus P bar divided by n. So UCL here is E2. E2 is P bar over here. So plus 3 times square root of E2 times 1 minus E2, which is P bar here, and divided by B2. B2 is n, and here is 50. So we got the answer, and we can slide it down also to get the answer quickly. And for LCL, it is the same, but here it is negative, so we can, the formula is just same as UCL, but we change here as negative, so we get the answer. But LCL here is negative, so if LCL is negative, we can change it to 0. So as my value over here, negative 0.037667133, it is approaching 0. So in Excel, I can easily use round down the cell to 0. So it will save you time, and just slide it down. There you go, you get 0. So how to plot this P chart? So P chart for y-axis, it is P, and for the x-axis is sample, and also included the CL, the UCL, and also the LCL. So we just need to highlight this for data. So insert here, I just use this 2D. So this is our P chart. P chart. And we can also name our axis. So this one is proportion non-conforming, or P, and here is sample. So as you can see, our P chart is not in control as the 18 data is out of the limit. So we need to plot and redo our P chart. So here I already eliminate the 18 data. So there are only 24 sample, which is G, but N is still 50, and the total summation of X changed to 80, and the N times G changed to 1200. So we can use the same formula for P bar, UCL, and also LCL. So as you can see, LCL here is also negative, so I can use round down to 0. There you go. So just slide it down and you got the answer. So this is our new P chart and it is in control.
Okay, I'll be doing question number 2. Let's see the question first. So this is the data for question number 2, which is a sample of 20, and I've been told to construct an NP chart for this data. I've already keyed in all the data from 1 until 20, and I've located X as this number of customers. So first of all, I am going to find the mean, and then what you're going to do is you're going to write the formula, which is that and average in the open bracket, and then just click on X and then drag it all the way down until that, and then you're going to close the bracket and then enter, and you're going to get 9.2. We're going to calculate the standard deviation. Oops. And then just do it like so. Drag, and there we have it. And then for the CL, you're gonna have to write the formula, which is equal sign, the dollar sign, C, dollar sign 1, enter, and then you're gonna drag it all the way down until 20, and there we have it. Next, for the UCL, the formula is C7, because we start from 7, C7 plus open bracket 3, we multiply dollar sign C, dollar sign 2, and then close bracket, enter, and then drag it all the way down, just like so. Next, okay, so for the LCL, we're going to write the formula, which is C7 minus open bracket 3 multiply dollar sign C, dollar sign 2, close the bracket, and then there we have it, and then just drag it down just like so, and then insert chart. As you can see, this is the NP chart. One is out of the range. So as you can see, let's say it is between 10 to 15, right? The sample of 10 to 15. So 10 to 15. 10 to 15 here. And this is the data, 9. And then, as you can see, one of the data is lying here, which is outside the UCL. So what we're going to do is eliminate the data. This is around 19. We are going to eliminate the data at 19, which is sample number 12. Next, I am going to eliminate the sample 12, this which has the data 19. Let's eliminate. So I'm going to eliminate this. Yeah. Delete this row. There we go. And I'm going to change this. 16, 17, 18, 19. And now, as you can see, we are left with 19 sample. Now we have to calculate the average, which is the mean. As you can see here, and now it's 10. After calculating the mean, I'm going to I already calculated the standard deviation, which is 2.9039. And here, the same with the same formula. As you can see, it is different from before. And then we are going to look at the chart. So this is the chart. It is much better, as you can see. Every point lies in the above line and the line below, as you can see. And so there is no more data that we have to eliminate. This is much better from the chart earlier.
Hello everyone, I am Nurul Najha and I will be explaining question 3 where asked to construct a C chart for the number of non-conformities. So firstly, first question, I will do some calculation. For the center line, I will get 7.56. For the upper control limit, I get 15.8086 and for the lower control limit, I get 0. So for this question, I'm using SPSS software to construct the C chart. I transfer all the information in the table in the question into the SPSS. As we can see, this is the column for sample and this is the column for non-conformities. And this is the C chart from the SPSS. As we can see, the upper control limit, the center line and the lower control limit value is shown here. And this is the straight line here is the center line, the dashed line here is the specification limit. And as you can see, there's a point that lies outside the specification range. This red point indicates that the number of non-conformities for a unit of the process is out of control, which means an assignable cost is suspected whenever the control chart indicates an out of control process. This chart shows that it is out of control process. So this red point here is for sample 9. Then I will remove the point from the table and reconstruct another chart. So I will clear the sample 9 and I will reconstruct the C chart. So this is the C chart after I recalculate the values and reconstruct the chart. As you can see, the upper control limit, the center line and the lower control limit has changed. So there is no point that lies outside the specification range, which means that the process is now in control.
Assalamualaikum warahmatullahi wabarakatuh and hi, I'm Nur Syamimi binti Adnan and I'm going to show you how to construct a control chart for the number of non-conformities U chart using Excel. So the question states that the number of non-conformities in carpet is determined for 20 samples and the amount of carpet inspected for each sample varies. Since the amount of each sample is various, so we need to use all these formulas to construct the U chart. First of all, we need to find the UI using this formula. UI equal to CI over NI. So we just CI divided by NI. And then we just need to click here and then we got all the values. Next, we need to find the center limit, which is center limit is equal to U bar equal to summation of CI over summation of NI. First of all, we need to find the summation of CI and summation of NI. And then we just use the formula summation of CI over summation of NI. Since we need to find the same values for all the U bar, we need to put the dollar sign here and here. Then we just drag, we just click here, and then we got all the values. Next, we need to find the upper control limit and lower control limit using these two formulas. We need to find the upper control limit first. U bar plus 3 multiply the square root of U bar divided by NI. Then just click here and got all the values. And then we need to find the lower control limit. We just need to change the plus into minus. U bar minus 3 multiply with square root of U bar divided by NI. Then just click here. So we got all the values U bar, upper control limit and lower control limit, and then we just need to highlight all the values and then click insert. This is the U chart that we got. The x-axis is the sample and y-axis is the number of non-conformities per 100 meter square. But this U chart is out of control because one of the sample is above the upper control limit. As we can see here, the number of non-conformities for the sample number 7 is quite large. That's why it's out of control. So the solution is we need to recalculate again and we need to exclude the sample number 7. So as you can see that I already exclude the sample number 7 and recalculate all the values. So we just need to highlight the U bar and upper control limit and lower control limit and just insert the chart. Finally, we got this U chart, and as you can see that this U chart is already in control. So that's all the steps that we need to follow to construct the U chart using Excel. I think that's all from me. Thank you.
Hello everyone, my name is Lowikit from Group E. I'm going to introduce the way of plotting control charts for attribute, which is the control charts for demerit per units by Excel. And this is the questions. The P-Core department store obtain feedbacks on customer certifications regarding a certain product. 20 random samples, each involving 10 customers. The customers are asked about the number of serious, major, and minor non-conformities that they have experienced. Clear definitions of each category are given. The results are shown below. The weights assigned to a serious, major, and minor non-conformities are 50, 10, and 1 respectively. And then we need to construct a control chart for the number of demerit per units. Here is our data. First, I import the data into the Excel, which from the sample 1 to sample 20. Okay, the first step we need to do is we need to import our weight first, which is the 50 for the the serious non-conformities, 10 for the major non-conformities, and 1 for the minor non-conformities. Now we need to calculate the total demerits. As we know, the total demerits for each sample is calculated by it times the number of serious non-conformity and its weight plus the number of major non-conformity and its and the minor non-conformity times its weight, and then we can get the total demerits. Here I show the first examples I do in here. We can see that I use this formula times 50 times 1 plus 40, then plus 2, and then we get 92. Okay, after we calculate all the total demerit here, we can calculate the demerit per units. As I mentioned just now, because we have 20 random sample, it's involving 10 customers. So for the demerit per unit, we need to divide the total demerits by 10 because we have 10 customers for each sample. We divide by 10. The total demerit divide by 10. After we calculate the total demerits and demerit per unit, we can calculate the means of non-conformities per unit for serious non-conformities. Here, the formulas for the mean of non-conformities per unit for serious non-conformity is we need to total the number of serious non-conformity divided by the total customers in those samples, which is 20 samples times 10 for each for the customer, which if we have total 200 customers in our total sample. In first, we can get 9 divided by 200, and then for the mean of non-conformities per unit for major non-conformities is also similar method. We already get sum is 74. We can get the 74 divided by the 200s. Then we can get the means for non-conformities per unit for major non-conformities. And then the last one, we also apply similar formula, which is we already get 114 divided by 200, and then is 0.57. After we calculate all the means for the different groups, we can calculate the center line of the U chart. As we know, the formula for the center line of U chart is it times its means and the weight. First, in here, we times the means of the non-conformities per unit for serious non-conformities and times its weight 50 plus the means of non-conformities per unit for major non-conformity, which is 0.37 times its weight, which is 10, and then plus the final one which is the mean for non-conformities per unit for inner non-conformity, which is 0.57 times its weight, which is 1. And then we can get the center line for the U chart. Here is the formula I applied for the U chart. And then final is the estimated standard deviations. The estimated standard deviations formula is the square root of the means of non-conformity per unit for serious non-conformity times the weights of serious non-conformity square plus the means of non-conformity per units for major non-conformity times the weights of major non-conformity square plus the last one, which is the means of non-conformity per units for minor non-conformity, which is 0.57 times the weights for the minor non-conformities, which is 1 square. And then we divide by the for each, because we have the 10 customer for each sample, so we need to divide by 10. So here is the formula I applies for the estimated standard deviations, and then we can get the value. After we calculate all these, after we calculate the center line for the U charts and the estimated standard deviations, we can get the upper control limit. Okay, the upper control limit is calculated by the center line of the U chart plus 3 estimated standard deviations. Here is the formula I apply. And then the lower control limit only a little difference to the upper control limit, which is the center line minus 3 standard deviations. But we get the negative value here, so we can just put 0. And then now we need to plot the graph with the Excel. For here, here is the value for the demerit per unit. This is our upper control limit, lower control limit, and center lines. We can use the functions. Okay, so for the insert these lines, and then we need to insert our values. First value is the demerit per unit. Yes, and then we also need to apply the upper, and then we add all the upper control limit, the lower control limit, and the center line. And then the final one is the center line. And then we already get the charts for the U charts, and then of course we can change the color, and then change the type of lines for the center lines. And then we can choose the option here to build the similar chart. Okay. After we build the chart, this is our U chart, and then we can see the process is under the controls, and then everything goes okay. And that's all for my presentations. Thank you.